So let's talk about some other named distributions that we have. So the next one is called the geometric distribution. And the geometric distribution, I think of this, I always go to Costco and I get the samples. My husband goes like every other day, seriously, and gets the samples of these, the food at Costco. So, but you always wonder how many people actually buy the food that's being sampled. And it probably kind of depends on the food. But in the interest of education, we're just going to say for right now that let's say Costco statisticians knows that the probability that someone will buy a certain product if they try it is 20%. So how many samples of food do they have to give out before at least the first person buys the product? So that's what geometric does. How many tries before the first success? So if you think about this, what is the probability that they get it on the first try? Well, that's going to be 0.2, right? Because the first person bought it. What's the probability they get it on the second try? Well, that means the first person didn't buy it. So that's 0.8 times the second person bought it. What's the probability it takes 3 tries? Well, that's the first 2 people didn't buy it and the third person did. So we get 0.8 cubed times 0.2. And you can see how this is going to go on. So the probability of x is going to be 0.8 to the x minus 1 times 0.2. Because this is the number of failures that you had. And this brings me to how you write it exactly. Actually, we wrote p first. So the probability of x is the probability of success times the probability of failure to the x minus 1 power. And that kind of makes sense because all of these are independent. We can multiply their probabilities. And the mean is 1 over p. So remembering that the probability that an American has high-speed internet access is 87%. What is the probability it will take sampling exactly 3 people before the first person is found with high-speed internet access? Now, we can do this by hand fairly easily by going 0.87 times 0.13 squared. So that's 0.87 times 0.13 squared. 0.0147. Now, we could also use geometric. So if I go second distributions again, you'll notice that I have one called Geomet PDF. So PDF, remember, the PDF is equals, CDF is less than or equal to. So I want the PDF because exactly 3. And my P, 0.87. My X value is 3. And I paste. And I get 0.0147. Exactly the same thing. So what is the probability that it takes at most 3 people before a person with access is selected? So this is the probability that X is less than or equal to 3. So now all we need to do is switch to Geomet CDF. So let's go to our distributions. And it's the very last one. And 0.87, so 0.87, X value 3, paste. That's going to be 0.9978. So that's going to be 99.78% of the time it doesn't take more than 3 people to find someone with internet access. So what is the expected number of people it should take to find the first one? Well, the mean is just 1 over 0.87. So we have 0.87 inverse is 1.15 people on average, of course. Okay, so last one, I promise. I know this is getting long today. The Poisson random variable. So that X is a model for data that represent the number of occurrences or specified event in a given unit of time and or space. So the number of calls received during a switchboard, the number of machine breakdowns, the number of traffic accidents, the number of people that enter an ER is a Poisson random variable. Lots of things are Poisson. At a given intersection or a stretch of road, like the Seward Highway, one of the most dangerous stretches of road in the United States. It's the stretch of the Seward Highway between Anchorage and Girdwood. Okay, so let's take a look at what it looks like. So the probability of K is mu. So this is the parameter mu. It's also the mean. So it's the average number of that event. So average of mu of such events is expected to occur. E, so this is Euler's constant. That's the 2.718-ish constant that you learned about in algebra, to the negative mu over K factorial. And K can be 0, 1, 2, ... forever. But just like in geometric, eventually the probability gets so small that you don't even really need to list it anymore. And the mean and the standard deviation, the mean is mu, the standard deviation is the square root of mu. Very, very simple. So I don't expect you to use this formula. We can also use the PDF or CDF on your calculators. So the average number of traffic accidents on a certain section of highway is 2 per week. Find the probability that there's exactly 1 accident during a 1-week period. So you'll notice, here's what they did. Mu is 2, 2 to the 1, e to the negative 2 over 1 factorial. That's all you have to do. Really breaks down easily. 2, and then your e is second natural log to the negative 2 power, enter, 0.2707. Now, you could also have done this. Distributions, go up to Poisson PDF like this. Lambda equals the mu. Some books call it lambda. It's the same thing. So that's your mu, so that's 2. And your x value in this case is 1. And you just hit paste. And 0.2707. So now I've asked you, what is the probability that more than 2 accidents occur? So the probability that x is greater than 2. Well, remember CDF is less than or equal to. So we need 1 minus the probability of x is less than or equal to 1, or 2, rather, more than 2. Less than or equal to 2. Because we want to take off the second one because we're talking about more than 2. So we want to take off the probability of 0, 1, or 2 accidents happening. So we're going to go Poisson, and now we're going to use CDF. Okay, and our mean is still 2. In this case, our x value is also 2. And paste. So the probability that less than 2 accidents occur is 0.6767, but we need 1 minus that number. So we have 0.3233. So there's a 32% chance that more than 2 accidents are going to occur at that intersection in a given week. So something that they might want to look at, right? So that is all. I'm sorry this one was very long, but we took care of a lot of different distributions today. So next time we start the normal distribution, and that's a lot of fun. And see you next time.